Let's do section 10.5, page 528, exercise 1, which reads, use the integral test to determine convergence or divergence of the series. And for exercise 1, we have a series that goes from n equals 1 to infinity of 1 over the cube root of n. Well, let's start by reviewing what the integral test says. And that says let an be a sequence of positive terms. Suppose that an, or the nth term, is equal to f of n, where f is a continuous positive decreasing function of x for all x greater than or equal to capital N, where capital N is a positive integer. Then the series from n equals capital N to infinity of an, and the integral from capital N to infinity of f of x dx either both converge or both diverge. So what this is telling us is if we can successfully figure out what the integral is going to be and it doesn't diverge, then that means that we know that the series will converge as well. So let's go back to our problem. And we are going to let f of x be equal to 1 over the cube root of x. And we're going to let capital N be equal to 1 because this function is going to be continuous, positive, and decreasing on the interval for 1 is less than x is less than infinity. And that meets all of our conditions for the integral test. And then we're just going to take the integral from capital N, which is 1, to infinity, of our function f of x, which I'm going to rewrite as x to the negative 1/3 dx. And of course, whenever we have an integral, we ask ourselves, first of all, do we know what the antiderivative of the integrand is? And in this case, we do. So it's going to be x to the positive 2/3. And I have to divide by that power, which is going to give me a factor of 3/2 in front. And then I'm going to evaluate that from 1 to infinity. And when I substitute in infinity and take it to the 2/3 power, of course I'm going to get infinity. And when I substitute in 1, I'm going to get 3/2, but that is still going to give me infinity, which means that my integral diverges. And if my integral diverges, then my series is going to diverge as well.